Hi, we are still trying to look at the full the list of topics that this administration, Linux administration course will cover. And we looked at the last week the features of Raspberry Pi OS and installations and package management. By the way, the real hands-on practice will be done each of these topics after we looked at the basic commands of Linux. When we have each one of us a Raspberry Pi device available. Okay, so the installation of the Linux on Raspberry Pi requires not only the Raspberry Pi device itself, but also you guys need to prepare the USB enabled mouse and keyboard plus the monitor. The monitor, if you have the portable monitor, that is perfectly fine. You can carry that to the class as you wish. Or once you set up at least the Raspberry Pi, the visualization, then you can use your laptop for your Raspberry Pi, the Linux Windows. So that until that point, we need a little bit of work. But at least probably in the coming, next class, we will practice the real hands-on exercise installation of Raspberry Pi. Okay. All right. Toward the end of today's class, I am going to show to you the potential the terminal that you may be interested in. Okay. So first topic is installation, and the second topic is the boot process. Raspberry Pi has. This is not only the Raspberry Pi. This is a general the Linux box booting process. If it is the case of a Raspberry Pi, then it has a bootloader that is on the Raspberry Pi OS. So this is the steps that you can think of when you power on the system. Then a firmware is being activated. For example, in Raspberry Pi, it has GPU firmware stored on SD card. Once we have to set up the SD card. On the SD card, we need to build a Raspberry Pi OS. And then a bootload system is learning. Okay, this bootloader will load firmware into the memory, and once the bootloader is available on your system memory, from that point, then that small program will bring up entire operating systems into the memory. So kernel can be initialized. Okay. And then system is initialized as looked at here, sys init and sysemd, system emd. And then finally you may be able to log in. And another very, very important topic in Linux administration is user and group management. So we are able to create user. Also, we can create, we can delete, we can modify user, and of course we can set and also change the password of the user. Once we set up a user, then the user, the owner of that user account are enabled to change his or her own password. So each user may be able to have different privileges. Okay, so this also a very, very important issue, and we will take a look at that in real exercise. Each user may be able to be in a group, so that we can create a group and add a user into a group. For example, group maybe in your Linux system, there may be a group called student, another group called faculty, another group called staff, and so on and so forth. And each individual user may be in the student group or faculty group. Okay. So system administrator has privileges to add a user to a specific group. Okay. And also, therefore, administrator can remove a user and delete a group, and also list a membership also. Then why each individual user needs to be involved in a group? Why? There are multiple reasons, right? For security reasons, you can set up a different set of privileges to a different group. Therefore, anyone that you create a user, and once you put that user on a specific group, then that user may be able to have his own privileges, and because that user is involved in a group, there is a user privileges as well. So it's very the handy way of managing the privileges, that type of things. And then we will look at the file systems and storage management. So we can partition and formatting disk and mount and unmount file systems. For example, what actually your operating systems is installed in a SD card, and in a Raspberry Pi there is a SD card slot, so you can put your SD card into that slot. Sometimes you may want to, hey, I want to use an extra, for example, memory stick, USB memory stick. Can I use that memory stick that can be accessed from my SD card operating systems? Of course, you can do that. For that, we can mount and unmount things. So that's type of all systems will be a file systems. Okay, so each file has its own file permission, and the user has also different granules of privileges. So they are securely matched. For example, this file can be read by this type of user. Okay. And networking, is another powerful and also very, very important tool that we need to look at. So configuring a network interface, manage DNS, domain name services, and configuring firewall also can be set up, and there's a firewall rules also needs to be set. And also DHCP, SSH, NSF, and more services may be able to installed on the network. So that can be handled by Linux operating systems, and Linux, that is also a job to be done by the Linux administrators, okay? And process management. Someone may need to understand clearly among those four terminologies: program, process, task, job. Each of these, they are very similar. As far as I want you to think of, for example, the programming, the code segment. That code segment, if it is not running yet, then a static set of instruction, we call that program, right? For example, your Python code, that is a program. We call it program, right? When that program is loaded on your computer, and if it is running, if it is executed, then it is called the process, okay? Therefore, your operating systems assign process ID and allocate some of the memory where that your program sits on. And if your program invoke other program, then it is a child process, and etc., etc. So as far as your program is on the system and being actively running, then it is called the process. Okay? And sometimes it is called the job. Usually managed in a shell, running in the foreground and background. So your program, when it is actively running on the system, we call it process. Your program may be running foreground level or background levels. In the case we call foreground job or background job. The same program that you can push back into that process, so that'll be a background job or foreground job. You can bring that, once it is running on background, you can bring it into the foreground back and forth. That is also possible in Linux command. That type of things are very easily handled. So you will be able to see that in our hands-on lab. All right. Okay, task is a unit of work. So in the Linux kernel, at the kernel level, it is called a task. A thread is a task. So there is a multi-thread. Then we call that multitask. That is more in the Linux kernels. And also another important topic, especially for cybersecurity professionals, then monitoring the system and logging all the system activities. On Linux operating systems, so many different programs are loaded, therefore lots of processes created and being active and push it back to background job and bring it to foreground. All those things can be very nicely scheduled. So it is one of the job of operating system is scheduling, okay? Job scheduling, or we can say scheduling among the process. If there is any specific tasks or actions takes place, then that may be logged, okay? Particularly every time user log in, that login process is loaded, is logged in the logging process. And more other the important series of actions needs to be monitored. So logging management, usually that is in the VAR directory, and each application program is a logging in the logging directory. There are lots of different loggings available. Okay, so to investigate your infrastructure, then you need to look at the logs and identify some of the instance and evidence. Capture the evidence. That type of things. Again, one of the important functions of cybersecurity professionals. So log management, monitoring tools. You can use some tools to look at, to find out activities of some of the processes using TOP or HTOP, IO TOP, and some network packet statistics, status. All those things can be handled. And system resource management monitoring tools. So we'll look at some of those when it comes to the real exercises. All right. So lots of those things will be discussed in hands-on labs. So again, it is very important to get your system installation, so on your Raspberry Pi. Okay. Online students need to contact the department secretary. Her name is Maria, or you can contact me. I know some of you already contacted me, so that I forwarded that to the Maria. So Maria will send you. Those who come and see me in a face-to-face class, then probably this coming Thursday, I will, when we come back to the lab at Mayor Hall 112, then I can distribute it to each of you, okay? And security. Of course, this is important issues. So the command that you can use in the security, the Linux command is chmod, so change mode of each file. So you can say, hey, this file can be accessed. Access in this case, three different ways of access, right? You want to access this file to read only, or write, or execute. So read, write, or execute. Those are three operations needs to be specified for each file. It is very it is clearly coded. Owner of a file can be also, and also attribute of the file may be able to modified by this CHATTR, and many others will be discussed. The firewall rules and intrusion detection program may be installed. That's for security purpose. And much others also available. All right. So till this is very basic things that we have to, each one needs to know all of this. But for example, if you are assigned to a data center of one of the Fortune 500 company, then you may be first assigned to backup team or recovery team. Then this is your specialties. Or if you are a good developer, then shell scripting and automation teams, and performance tunings. And particularly if your company designs and run multiple databases, then each database there is a database administrators. So we call it DBA. So there is lots of the tools and applications that you have to run. Of course, web administrators, that also something that you have to be aware. And then cloud system managers. So a little further, then for backup, there is a backup strategies needs to be set. Whether you want to back up fully, how often are you going to do that? Or sometimes you can back up or some incremental positions, incremental portions only. Or something. This is from differential backup or incremental backup. The tools are available, many of those. DD, there's disk dump, disk dump. Usually, if you want to do forensic investigations, then you need to do disk dump. And TAR, this is for in order to archive. TAR means tape archive. And cron jobs may be set up. So, for example, at every morning, very early in the morning, for example, 2 o'clock in the morning, our system automatically back up different, only something different from the backed up yesterday. And also Saturday morning, maybe incremental backup or full backup. All those schedules needs to be set up in these cron jobs. So this is also a very interesting the exercise that we will do. Kernel management. So kernel modules may be upgraded, modified. And then shell scripting, write a shell script. So using the command, Linux command, series of Unix commands may be like a coding, okay, Python code. But it is very powerful because each line of code means much. It's not only single small instruction, but it could be to run a big job. But you have a sequence of those lines available. So we call that shell scripts, bash shell. Well, actually we use bash shells. So automating tasks with the cron job, on the cron files you set up how often this program runs. Okay, that can be done. So once you set up a shell script, once you write a shell script, then you can run that shell script by scheduling on this cron. Visualizations, of course, this is more handy, and naive users may be able to understand if it is well visualized. It's a more demonstration purpose. And the configuration management. The tools and application, once installed, but continually needs to be updated. Okay, so new configuration needs to be managed. As you update, here on this system, not only operating systems, but all kinds of software packages needs to properly managed for supply chain issues. So software packages needs to be supplied periodically, and therefore the package installed and running on your systems accordingly updated or improved. That is a supply chain issues. Like in databases, if we have some produce supply chain, then like cherry tomatoes, apples may be supplied from East Coast or West Coast or South Americas. Each different produce needs to be well supplied, right? Similarly, exactly the same issues in the software management. Therefore, it should be properly configured. And performance tunings, network tuning most likely, and also disk I/O tunings. Therefore, the programs which stored on your hard drive can be efficiently loaded on your memory and therefore handled by CPU and GPU, right? Over the course of a network, data can be efficiently transmitted back and forth. That is network tunings. And high availability load balancing. If you have a limited the resource, then, but if you have so much overwhelming the data content needs to be served, then you have to utilize your resources equally. Therefore, you can avoid one system running, overwhelmingly. The other system maybe idling, right? It's no good, right? So the load of work needs to be well distributed, well balanced. That can be handled by ad hoc the capabilities of a system or network administrators. Database administrations on Linux. We will build MySQL on our Raspberry Pi, and that the data in MySQL can be accessed through web server. So we can set up Apache, and if we have PHP programs, then PHP program will be sitting on in the middle of web and databases. So we call them middleware. That will be done also. This is another very useful the exercises. So lots of things that we will do in this class. Finally, cloud and hybrid environment. We don't do much for this, but this is more, big global system architecture, but ours is a small Raspberry Pi. But if you have, for example, 100 Raspberry Pi, they're all connected, and if you are handling all of those 100 Raspberry Pis running properly, then that will be nothing but a cloud services. In that case, you may need to consider. So the practice that we need to consider is listed. We need to use, for privileges, what is the principles of the manipulate user privileges? Then with the least privileges, we want to set up the environment so that user may be able to work efficiently. Okay, so, and also package and kernels needs to be updated regularly. And if we set up firewall to protect our systems securely from any unwanted intrusion or attack, then firewall needs to be set up properly, and the rule needs to be clearly defined and periodically cleaned out. And secure shell authentication needs to be also, this shell key needs to be well managed. And monitor log, monitoring things, and more. Okay? So today's lecture is to list the full features of the jobs and activities that you need to do as far as you are on Linux operating systems. Particularly as a Linux administrator, then you need to look at all of this. Once you know one, then you may be able to understand a little bit similar other applications as well. So we overview the full features, and from next class, we start to install the operating systems on Raspberry Pi. Thing is this, once we set up operating systems on each of our Raspberry Pi, that'll be done only one time, and after that, we move forward, exercise and learn more Unix commands, one commands after another and another. We practice and move so quickly. Therefore, if you are not ready from the beginning of this, the hands-on exercise, you may be in big trouble, and also it gives you big stress. Okay, so I want to make sure each one of you, I mean, almost all the students get the Raspberry Pi ready and run at each class. Some students do not bring Raspberry Pi to class, only listen. You don't gain the skills if you sit down and only watch what we are doing. You really need to do this hands-on, right? You have to practice on your own. First time failure is okay, right? There's no one can succeed from the first shot. The more that you failure, the more skills that you gain. This is true, right? If you are lucky, therefore, every time you issue command, it works, then you don't really learn much. You learn that much. But if you keep failing, then in order to make it work, then you need to do this way and that way. Doing so many different trial and errors, you will end up gaining big advantages. Okay, so don't be frustrated. Don't be stressed. So that is a learning curve. Only thing that you need to do is to keep doing that. If you have some issues, the best way that you can resolve, the first step is do on your own yourself at your best. If you cannot, then you can bring it to me. We'll sit down and look at. But when you carry this Raspberry Pi, you have to handle it very carefully. That is an electronic device. It is not really 100% robust. Reliability is very high, but it is not a zero defect. It depending upon the user. If you do not handle it carefully, then your device may not functioning well. If it is the case, then that is the miserable, right? Because this class and exercises and hands-ons completely 100% requires a real device, Raspberry Pi device. Sometimes you can do a little bit of work if you have your MacBook, because the MacBook has Linux running behind it, so you can practice a little bit, but not exactly the way that we do on Raspberry Pi. A little bit of discrepancies. All right. All right. So this is the lecture, second lecture of this semester. So from the third lecture, I think we will start installation of the Raspberry Pi. Hopefully, yeah. Oh, before I forget, as I said, I'm going to look at, let's say, best way that you can look at is Amazon. I want to look at extra monitor for laptop portable. Maybe look at this. Yeah, this type of a monitor is really, really good. So about $70. This type. This is too big. You don't need that. This is also good. This is too big, right? This is 24 inch. I am talking about maybe 13 inch, 11 inch, 10 inch, that type of small things. 15 inch, that is still big, but ideally 13 or 12 inch monitor enough. But it is really nice. The size of a monitor is similar to the size of your laptop monitor. Okay, then you can put them side by side, so you can have an extended display. That is really good. Is there any small ones? I think there's some small ones also. I would just say small. Small monitor. Maybe this is a small for this is particularly the red for Raspberry Pi. This is a 10 inch, which is handy. This is 7 inch. 7 inch is okay also. All right, so you can carry this, but it's not really required, because I will put extra monitor in the next class on the lab for face-to-face class. For online class, you can do on your own. You can use your home TV if you have a smart TV. Where as far as it has HDMI, the cable available, then you can use it. For the class, if you want to bring it back and forth, then this type of small things, okay. But if you set up successfully, for example, BNC, virtual network computing. Let's see if I have that. No, there is an application. Oh, where is an application? Oops, there is no application. Here, applications. Then there is a VNC viewer, right? Using this VNC viewer, we set up a VNC viewer on your laptop and also set up a VNC capabilities on your Raspberry Pi, then they communicate to each other. So your Raspberry Pi monitor terminals may be able to be seen on your laptop monitor, okay? So once you set it up, but in order to set up, then you need the monitor. Otherwise, first time that we have to set up the monitor, and then, so we'll do that later. All right, so I'll stop the lecture, and I'll see you next time, all right?